Good morning all. This is my supercapacitor speaker project. There's the chip TDA7492. Here are all the supercapacitors and the speakers. But just before I get back into this project, I wanted to do something, a fusion between that project and this electric toothbrush. So when I did a teardown of this electric toothbrush, which is a sonic toothbrush, is that the on-off switch? No, that's the on-off switch. So you can hear that. It is a sonic, in other words, an audio frequency, and it has a sort of fixed frequency mode and a sort of wobulator frequency mode. I suggested that the coil mechanism up here, the motor, I suppose, in a sense, that oscillates this backwards and forwards, was akin to a voice coil, and the comments, there were many suggestions. Well, why don't you connect the speaker from your supercapacitor speaker project to the output of the toothbrush and see if you can hear what's going on in this voice coil more easily on the speaker. So that's what I'm going to do. So while the soldering iron warms up, let's disconnect the speaker, which is an 8-ohm speaker, from the amplifier. And these wires I'll solder onto the board so that whatever's driving this voice coil, well, it's the toothbrush motor, will drive the speaker cone. Just before I do that, I'm going to unsolder the wires to that motor, and I'm just going to check the DC resistance of these two devices just to see whether they are similar. So first, this 8-ohm speaker. Now I know that's 8 ohms impedance, but yeah, actually that's giving us, this meter's all over the place, but it's giving us approximately 8 ohms of DC resistance. Let's check the toothbrush motor. Just unsolder that from the board. That's one wire. And the other wire. Right, let's check the resistance of that. And it is, if I can get that on there. No, I can't. Oh, come on, what's going on here? It's quite tricky to get those on. Okay, so that is, oh, well, that's interesting. It's kind of 4 ohms-ish. So certainly less power will be developed by this unit into this 8-ohm speaker, but that doesn't really matter because it's going to be much more efficient at producing the audio tone than that motor will, because there's no diaphragm. So right, let's connect this speaker to the toothbrush and see what it sounds like. Right, and let's solder these on. Doesn't really matter which way round they go. I suppose I could work out which is pos and neg, but I'm not going to. That's neg, and that, if I can get it hot enough, is pause. Right, let's see what it sounds like. Right, that's the on-off switch. Oh yes, a very nice audio tone, quite loud, something bouncing around in there. And that's the wobulator mode. That's off. Now what about the power levels? That's maximum. These must be pulse width modulated. So let's put it on max power. And that's the wobulation sound. Yeah, so that's what a sonic toothbrush sounds like. It's pretty good. Ah, right, something I didn't do, which was to turn this on. This is the 3 different power levels in continuous tone mode, but the different power levels in wobulator mode are quite interesting. And that's what goes into your teeth. I must admit, I don't use a sonic toothbrush myself. I use a Braun one, which just the head rotates. I'm not sure I fancy that frequency going into my teeth. Might set them on edge a bit. Of course, the flip side to this experiment would be to take an audio amplifier like this and connect its output to the coil of the motor that drives the toothbrush backwards and forwards, because I mean, if it's been worked out that a tone, and I seem to remember that people were saying this was about 500 hertz, a 500 hertz tone driven into a toothbrush head cleans your teeth, well then surely music would clean your teeth. So there's a really brilliant idea for a new product. Musical MP3 toothbrush with an SD card slot. Play your favourite tunes straight into your mouth. Go develop it. Make some money. Cheerio.